So moving on to example 4. So this time we have the cotangent function. I'm also noticing that I have a coefficient on theta. So even though I have my restriction of 0 to 2 pi, I am remembering that as soon as I find my angle measures, I'm also going to have to take into account the period. Okay, so if we have the cotangent of 2 pi, so 2 theta over 3 equals negative square root of 3. I have not memorized my cotangent values, so I am going to change this in terms of tangent. So this is going to be equivalent to the tangent of 2 theta over 3. Notice it's not the reciprocal of the argument. It's the reciprocal of the value of the output of the y value. So this would be equal to negative 1 over square root of 3. So the tangent of 2 theta over 3 is equal to negative square root of 3 over 3. Okay, so looking at my unit circle, I'm looking where the tangent is negative. It's not negative in the first quadrant. It's not negative in the third quadrant. So thinking about this, I am looking and I realize that that corresponds to the point square root of 3 over 2, 1/2, and negative square root of 3 over 2, 1/2. Okay, so I see that my argument, 2 theta over 3, needs to be equal to 5 pi over 6. But I also notice my next value, right, 11 pi over 6, is pi units away. So instead of having to add, listing the two different values and adding 2 pi n, instead I'm going to notice that this is 5 pi over 6, and because the period of tangent and cotangent is only pi, I'm going to do plus pi n, where n is an integer. Okay, but now we still need to solve for theta. So I am going to multiply everything by 3/2. So this becomes theta equals 5 pi over 6 times 3/2 equals 5 pi over 4 plus 3 pi over 2n. Okay, I still have my n as an integer. So again, I need to put 2 pi in terms of fourths. Okay, so this is going to be 8 pi over 4. So theta, I'm also going to put this in terms of fourths. So this is going to be 6 pi over 4. So right away, I can see if I use any negative integers, if I use negative 1, I would get a negative value, which is outside. So now I'm going to let n equal 0. This becomes 5 pi over 4. If I let n be 1, this becomes 11 pi over 4. Okay, so but 11 pi over 4 is outside of my range. So my only answer is going to be 5 pi over 4. Okay, you can also plug in this theta into your original equation. You can even do that with your calculator as long as you're in radians and confirm that that's your correct answer. Okay, moving on to example 5. So again, we have those restrictions. We're looking for our values between 0 and 2 pi. So the nice thing is that our sign, the argument is complicated, but the actual sign function is isolated. The sign of this argument is equal to 1. So again, we're looking at our unit circle and we're thinking, where is the sign equal to 1? I think you'll recognize that it's on the y-axis at the point 0, 1. Okay, so this argument, what's inside the parentheses? Needs to equal the angle that corresponds to that. And that is pi over 2. Okay, but also because this argument, right, that's not the only, we need to, because this argument has a coefficient other than 1, we need to take into account the period. So we also need to put plus the period of the sign is 2 pi n. Okay, so if I subtract pi over 18, sometimes people get confused here. Okay, you do not need to subtract pi over 18 to this 2 pi n. It's not a like term. When you add or subtract, you don't do it to every term, you do it once on each side. Okay, same as with our linear equations. If you're multiplying or dividing, you do it to every term, but if you're adding or subtracting, you only do it once on each side. Okay, so this becomes 3 theta. I'm going to put this is 9/18, right? Minus pi 18ths makes 8 pi over 18, which is 4 pi over 9. And I still have that plus 2 pi n. Now I need to divide everything by 3. Remember, if you're multiplying or dividing, you do it to every term. And I get theta equals 4 pi over 27 plus 2 pi n over 3. Okay, so my 2 pi in terms of 27ths is going to be 54 pi over 27. And I am also going to think that my 2 pi n over 3 is going to be 18 pi n over 27. Okay, just to make my arithmetic a little easier. So obviously if I subtract 18 pi n over 27, I'm going to get a negative value, so I don't have to worry about my negative n's. When n is 0, I have 4 pi over 27. When n is 1, I'm going to have 4 plus 18, which is 22 pi over 27. My next one, when I have it, 2 of these, I have 836 plus 4 is 40 pi over 27. And my next one would be 18 times 3 plus 2 pi would give me 58 pi over 27. Okay, but that 58 pi over 27 is outside of the 54 pi over 27. So these would be my answers. Okay, I have 3 solutions. 4 pi over 27, 22 pi over 27, and 40 pi over 27. Okay, example 6, almost getting there. So I need theta minus pi over 2. I need to think about where my tangent is 1. So I am thinking my tangent is 1 when theta equals pi over 4, or when theta equals 5 pi over 4. Okay, so my argument this time though, I'm going to say it's equal to pi over 4. And I could say 5 pi over 4, but again, whenever we're dealing with the tangent or the cotangent, these are pi apart. So instead of saying plus 2 pi, I'm just going to say plus pi n. Okay, now to solve for theta, I'm adding pi over 2, okay, which is the same as adding 2 pi over 4. Again, when you add or subtract, you only do it once to each side. When you're multiplying or dividing, you have to do it to every term. So this becomes theta equals 3 pi over 4 plus pi n. Okay, so in fourths, I'm looking for 8 pi over 4 as my outside boundary. I'm going to add this is 4 pi over 4. So obviously if n is negative, I get into the negatives. So that wouldn't be inside of my restrictions. So my theta when n is 0 is 3 pi over 4. When it's 1, it's 7 pi over 4. If I add another 4 pi over 4, I'm going to see I'm outside of that 8 pi over 4. So these are my two solutions. Okay, so for our last example, we want to make sure that our calculator is in radians. Okay, and the reason I want it in radians is because my problem says express the solution in radians, rounded to 3 decimal places. Okay, a lot of this process is the same, but I think you'll recognize that 0.3 is not one of our known special angles, right? When the sine of theta is 0.3. So I'm starting this process the same. I'm drawing in my unit circle and I'm thinking, where is the sign positive? So I know the sign is positive in quadrants 1 and 2. So I am crossing out quadrants 3 and 4. So we are going to use the inverse sign, okay? So theta is going to equal the inverse sine of 0.3. Okay, again, very important that you have your calculator in radians. But then when you find your, you can find this with your calculator. So the inverse sine of 0.3 is going to be 0.305 about. So this, our theta, is going to be about 0.305. Okay, and thinking about this, the inverse sine is defined in quadrant 1 or quadrant 4. So this angle right here is about 0.305. Okay, but now let's think we need to find the solution over here. Okay, and so this part right here needs to be about 0.305. Okay, so for our quadrant 2, our theta is going to be pi minus 0.305. Okay, again, you want to use pi in your calculator, not 3.14. And so doing that in my calculator, I get that this is about 2.837. Okay, and again, I'm looking for my values between 0 and 2 pi. My argument of theta in my original equation is 1, so I don't have to worry about taking in the period. And I found the two values. If you plug these into your calculator, sine of 0.305 and sine of 2.837, you should get 0.3.